Hey everybody, Dr. Yeager here, and you know I'm not going to be in class today. Professor Savannah is going to help you out with today's in-class exercise. Today you are going to calculate the speed at which the Pacific Plate is moving, and you're going to do that by measuring the distance between several volcanoes and seamounts out along the Hawaiian and Emperor Island chains using Google Earth. It's pretty straightforward, and I think you'll have fun doing it. So the first thing you're going to need to do is open up the place marks that you're going to use to measure in Google Earth. Now, luckily, if you're using a computer in the classroom, most of them already have these files saved on them because students worked on this project with me yesterday. So to see if your computer has one of those files, you simply need to look and see if you have a folder out there called Hawaiian hotspot place marks, and it'll be on the desktop in a zip file. If you have that there, just open up those files in Google Earth, or open up Google Earth and go to File, Open, and then you can see these files there. Just open those up in Google Earth. When you open them up in Google Earth, here's what you're going to see. You're going to see a place mark for each of these files, and most of these are either active volcanoes down here, non-active volcanoes in here, and what we call seamounts. And here you're going to read about what those are. And then in addition to that, you have something called the Loihi Seamount. And the Loihi Seamount is the place at which the geologic hotspot at Hawaii is. So this place right here is the place where all of the Hawaiian Islands and all of these seamounts was all formed. You can see at one point every one of these places was sitting right on top of that where that seamount is today. And that Loihi Seamount is actually the newest Hawaiian island that is being created underneath the sea right there. So that's pretty interesting. Anyway, you're going to use your lab, and your lab over here starts out like all of them do with some background information. Just like always, please don't skip the background information. On the second page, you are given explicit directions on how to complete the lab. Explicit directions meaning it tells you exactly what to do, so don't skip over that. And then on the third page, you get to the actual meat of the lab, and this is the table that you're going to fill out. Okay, so we've got a table here with all of the hotspot, the Loihi Seamount right there, and then some volcanoes and some seamounts and things like that here. We're going to fill out this table that has the age. MA means millions of years. We have a column for that. We have a column for the distance from the hotspot, meaning how far is each one of these things from the Loihi Seamount. And then we're going to calculate how fast the plate is moving and some other things. But the first thing we have to do is fill out the age. How old is each one of these volcanoes or seamounts? I've got the first three started for you just to get you started. And if you want to fill out the age for any one of these, it's really simple. You just click on the place mark. So I'm clicking on the one for the Laysan volcano right here. You click on it, and it tells you that the volcano is 19.9 million years old. So you just come over here, you type 19.9, and there you go. You're good to go with that. When you want to, so do that for this first column here, and do all of column 1 first, then move on to column 2. Column 2 is where you're going to use the ruler tool or the measuring tool in Google Earth to measure the distance from the Loihi Seamount to each one of these place marks. Okay, so by now you are familiar with the measuring tool in Google Earth. You've used it in your Google Earth exercises. You click on the ruler up here, and we are asked to give the distance in kilometers, so make sure to switch to kilometers. And all you're going to do is measure from point to point, and it's going to give us a number. So that is the distance from the Loihi Seamount to the West Maui volcano. I've already got that filled in for you, and you see it's pretty close. It's not completely identical. Your answers will not be completely identical to mine. So you're going to do that for each one of these volcanoes, okay? And then you're going to fill in the amount. Make sure you can measure in a straight line until you get out here to the Kamu Seamount, and then once you get past Kamu, you're going to have to not use the you're not going to be measuring in a line. You're going to be measuring in a path, and so when you get out to like the Koko Seamount, you're going to come out to Kamu and then measure up that way, okay? Because you need to follow the path that the plate took. Anyway, you're going to fill in column 1, you're going to fill in column 2. Once you fill in column 1 and fill in column 2, then and only then can you fill in column 3. You can't fill in column 3 until you got 1 and 2, because you're going to use column 1 and 2 to get column 3. So to figure out the speed of the plate movement, how fast the Pacific plate is moving in the time since each one of these volcanoes was born, you take the kilometers, which is this column here, and you divide that by the million of years, which is that column there. This over this equals this. Okay, so go ahead and do those calculations for all of these volcanoes here. When you're done with that, down here at the bottom, figure out the average. So figure out the average for each one of these volcanoes here, okay? Once you've figured out the average, you can then come over here and figure out column number 4. What we want to do is we just want to figure out how each one of these numbers, in terms of the speed of the plate moving during the time frame since each one of these volcanoes was born, we want to figure out if it's moving faster than average or slower than average. So we figured out the average down here in this cell right here, and you're going to come up here and you're going to subtract the average from this number. So let's say if the average is 112, you're going to come up here and you're going to get 196.48 minus 112, and so that's whatever that is, 84.48 or something like that. And you're going to do the same thing here. You're going to minus 112 from that, and you're going to minus 112 from here, and so on and so on. You are going to have positive and negative numbers here, okay? Some numbers are going to be positive, some numbers are going to be negative. So that is okay. And then just use the numbers up here to answer the questions down here. You don't have, remember, all we're calculating is the speed of the plate movement. Don't try to read too much into these questions. We can only use the data that we have here to answer the questions. All right? So make sure to ask questions of Professor Savannah if you have any questions, and do your best, and we'll see you in class next time, okay? Y'all have a wonderful day.